So recently I came across this USB spectrum analyzer that is actually being flooded on eBay now with lots of different Chinese sellers. It's a simple USB analyzer. It plugs into your laptop, but you also need a noise source to go along with the analyzer itself, and the same seller was selling these noise sources to use in conjunction with the analyzer. But unfortunately I haven't been able to test this for any length of time because this noise source gets extremely hot. Now this noise source actually works off 24 volts, and these resistors on here get extremely hot, and I mean hot. You will actually burn your fingers when this has been on for 30 seconds or more. By the time it warms up, you would literally be able to fry an egg on this. So before I actually use this for any length of time, I'm now looking at adding some kind of heatsink to it, but the problem I've got with this is it's not level on top of here, so I can't really add anything on the top here to dissipate any of the heat. And also on the bottom here I can't add anything to the bottom because the PCB itself is such a poor conductor of heat. By the time this side gets warmed up enough to actually start transferring some of its heat away, it means the resistors on top are extremely hot, and probably hot enough to actually start melting the solder on the joints here. I'm not exaggerating, it gets that hot. So to actually get rid of the heat more efficiently, what I've decided to do, I've got a metal cast alloy project box here, and what I'm going to do, I'm going to mount it inside that project box. I'm going to remove the SMA connector here and the power connector, the power jack from the back, and I've got a panel mount SMA connector here that I'm going to replace it with, and also a panel mount power connector, and I'm going to drill into the sides of this case, mount these connectors, because then what I can do is actually waterproof them from the inside. I can have this positioned halfway in the actual case itself, and then I'm going to fill this case with some mineral oil and then seal the top back on with some silicone sealant and screw it all back down, and that mineral oil will actually help dissipate that heat away from the noise source, and then hopefully I will have a slightly longer lifespan from the noise source itself. Now using something like oil to actually dissipate heat is being used for quite a long time in the electronics industry. You've probably seen the videos on YouTube where people have put their computers into fish tanks full of mineral oil, but it is used as a legitimate heat dissipation method in the industry. Big transformers actually have been used in baths of mineral oil for quite a number of years. Now I don't think for 2 minutes that something that costs £45 off eBay that you plug into your laptop is going to replace this lot. But there is actually a gap in the market for something for the hobbyist to actually use to measure antennas and simple RF equipment that you probably build in your hobby lab, because the only other option is to buy older equipment that's now obsolete, and a lot of the equipment I've got here comes from the 1970s, but it still costs quite a few hundreds of pounds to actually buy. So something like this could be a little gem to have if it actually works. So I've got all the connectors soldered on now, and I also forgot about the LED, so I've modified that as well, put a longer LED on there and drilled a hole in the end of the box here so we can actually see when it's powered on. And what I'm doing now, just before I actually start mounting it in there, I've got some silicone sealant, and I'm just putting it around the edge of the connectors before I actually clamp them on, screw them onto the sides of the box itself. And it's just this general purpose silicone sealer. So that's with the silicone sealant on it. It just makes its own watertight gasket around there, so when we put the nut on it should be nice and sealed up, won't get any leaks. So that's that connector all gunked up, and hopefully it's going to be watertight, or should I say oil tight. And it's also, when you're doing this, a good idea to keep the jack plug connector in there, just so you don't get any silicone on the inside on the contacts, and then you're not going to get power going through. But hopefully that's going to do the job. And that's the SMA connector all gunked up, ready to go in place. And I didn't put any heat shrink tubing around this connector either, so I could get in there and gunk all that up inside there, so it makes it all nice and watertight. So hopefully we won't get any leakage through the centre pin on this SMA connector. And as for the LED there, I've just put gunk around the hole in there, so hopefully there's a little ridge around these LEDs, so that'll squash up against there and make its own little gasket, hopefully. So I've left this overnight for the sealant to set, and what I'm going to do is top it up with oil and just leave it without putting the lid back on, just to make sure that there's no leaks. And also I just wanted to point out that this header here is the positive and minus for the power. It's connected in line with this, so if you didn't want to actually desolder the power jack, you could actually get this header and solder directly to that, or add your own homebrew connector, so you didn't have to remove the actual power jack itself. So I've now got the actual noise source switched on, and it's immersed in the oil, as you can see. I've got a temperature probe in there, just keeping an eye on it, and in the 30 minutes it's just slowly crept up, and as you can see now it's at a maximum of 32, climbing up to almost 33 degrees C. So a lot more usable now, and you can just touch the side and it's just slightly warm. So I've gone round now and I've put silicone all around the edge of this, and also some on the lid itself, and I'll just squash it down and just wipe away the excess. So I've been using this signal source noise generator now for the last 3 days, and no leaks whatsoever, so I'm really pleased with how this turned out. And of course I can use this for a decent length of time. I've got it on for an hour and a half at a time while I'm doing measurements using this USB spectrum analyzer, and so far I'm quite pleased for the money how this thing is turning out. It's of course it's not going to replace anything that's cost thousands of pounds, but you know, for the hobbyist it's not bad, so look out for a few more future videos on this. So if you found that useful, as always, please give it a thumbs up, and hopefully I'll see you on the next one.